Okay. Is it recording? Yeah. Oh, cool. That's easy. Yeah. So we'll finish everything up next week, and then can I ask, Hannah, I've never taught this format as a night class. I usually teach this splitting between 3 days or 2 days. So if you guys had the night, who else had Adam at night last time? Who did? Who else had Adam? Nobody else? How did he do his testing? I've heard he's a really good elementary school teacher, so I bet you he's, I don't know.
He would teach more content in the first half of class, and in the second half we took our test.
Oh, I didn't want to do that.
It was rough.
All right, so this is what I was thinking. I don't want to do that.
Yeah.
So,
we were learning new things, because he was like, well, we have too much to learn.
We do have a lot to cover.
So I can't just not teach one night to take a test. So we all would test at different times. Well, we'd all start at the same time, but we'd all finish different times.
Yeah.
So he didn't want us to all wait for the second half of class and teach.
Yeah, that makes sense. So yeah, that totally makes sense. That was smart. Yeah, that was smart.
In the beginning of class, which confused all of us.
All right, I don't want to do that. I was thinking about that walking over here. So we'll get everything done. I think this is what we'll do. We'll get everything done next week. So I think what I'll do is I'll have a review, because I usually review a whole class period before a test. So I think what we'll do is I'll give you, who had 1140 with Julie? I thought some people in here said they had Julie as well.
I took 1140 with Adam.
Okay. So I was trying to figure out what they did at night. So I think what we'll do is next week I'll give you a review packet. I'll just give you an old exam. And then you'll take it home and you're going to do it. Okay? And then we'll go over it when you walk in the door. So you'll try it first. And then I'll probably give you a key. And then it's not going to do you diddly do if you don't try it beforehand, right? So then you're going to check and see how you did. Is that okay? You're going to check and see how you did. And then, so we'll take an hour, a little over an hour to review. And then we'll take the test and then we'll go home. Does that sound good? Because I was trying, what? Yeah, so we'll finish everything next week. And then we'll take the test the week after. So then we'll have time to get questions answered about Venn diagrams, and we're going to do a lot of Venn diagrams next week, and that tends to give people a lot of grief, but I hate just giving you a test on it the next week without having time to ask questions on it. So normally, as Sean knows, we just take the whole time and do a review, but then so this way we're not wasting any time. You'll have to do the review at home first instead of in here. Then we'll go over it. Have lots of times to answer any questions, so no new materials, just stuff we've already done, and then take the test. And then as soon as you're done with the test, you can go. Does that sound good?
Yeah, I hated having to come in. He'd give us a review packet, and we'd do it, but we would never go over it.
Oh.
So, we literally
In Adam's defense, I've heard he's a really good elementary school teacher, though.
My niece had him.
Yeah, they love him. Kids friggin' love him. So I've never seen him teach, though, up here. Yeah, I've heard that kids just love him as a teacher. So I guess everyone likes others. Some people can't stand me. Some people like me, whatever. I don't care. Whatever. I do the best we can. We do the best we can. All right. Okay, so that's what we'll do. So next week we finish everything up. And then the next week we'll review for an hour or so. Take a break. And then when you're ready for the test, we'll give you the test. And you can take as much time as you need. And when you're done, you can leave. How's that sound? I think that's how we'll do it. Because I'm just playing it. Again, I didn't know I was going to teach this class, so I hadn't really thought about all this. So I was walking over here, I'm like,
he must have decided not to come back this semester.
oh, I don't know. My department said, hey, you're going to teach an extra class. I said, I am. Oh, my God. Okay. All right. Because I was already teaching overload, so this is a lot of overload. That's good. I like to. This is my favorite class. I think this is fun. All right. This one is a beast. This one, you have one very similar to it in the homework. This is a pretty typical part 2 question where you love it or not, you take it or leave it. There's a bunch of ways to do it, so we're going to take our time with it. And I look at it like this, where we break it apart. You break it into 2 sections. Like here, they broke it into colors. Here, you want to break it apart into however you see it. Now, I see it as a rectangle with 2 little jutty things sticking out. Other people see it as a square with a top and a bottom. It just depends. Oh, that's how Sean sees it. So I see it completely different. So we'll do it both ways, and we'll end up getting the same answer both ways. Okay? Oh, there is one of these, and I'll show it to you next time. Looking through the books, that you did have a patterning question, kind of similar to this on the certification exam. But I'm going to get through this, and then maybe we'll start every class with a practice that I found that's similar to this. That sounds good, right? Just start it with a problem. All right. So let's do it my way first. Because I see it as, a rectangle with two juts. A rectangle with two jutty things. Do you see what I mean? See what I mean? I don't know what they're called. They're just like jutty things. A rectangle with two jutty things. So it's a rectangle plus two, I don't want to write the word jut because I don't even know if that's a word, plus two squares. Okay. Two squares. All right. So if you added up the boxes in the rectangle, it's not arithmetic and it's not geometric. It's neither. These kinds of problems deal with dimensions. And that's where the arithmetic and the geometric or the pattern recognition comes in. And I guarantee you'll get good at it. It just takes a while. So here, first figure, second figure, third figure, fourth figure, fifth figure. All right, and remember, if you can do the fifth figure, you've seen the pattern. You can't get away from it if you see it. All right, are we ready? Who we got? Chloe. What are the dimensions on this fourth figure? What by what? 3 by 5. Fourth figure, 3 by 5. Marissa, what's the dimension on the third shape? Which one? Are you good? I'm gonna learn everyone's names today. I think I'm there, but just trying my best. Colin, help her out. What's the dimension on the third figure? Help her out. Yep. Perfect. I'm going to go 2 by 4, just because it's small to large. That's how we started it. Be good, Marissa, do you see what I'm talking about? It's like the rectangle. I want to know the dimension of the little rectangle. You good? Okay, Nicole, what about this guy? Second shape, what is it? 1 by 3. Okay, so check it out. If you guys can give me the fifth dimension or the fifth shape, you can tell me what it is without drawing it, then you've seen the pattern.
4 by 6.
Perfect, 4 by 6. Do you see it's 1 below and 1 above? All right, so now you can do the nth. So if it's 1 below the n, then it's going to be n minus 1. And if it's 1 above, n plus 1. Then plus 2, because you got the two little jutties. So you've got n minus 1 times n plus 1. There's the rectangle, plus 2. So I don't care if it's the 100th term, the 200th term. You just stick in the 200 and go for it. Is that okay? All right, I don't know how far advanced they have you simplify this. Like, it's such a bummer to get there and then you look at the answers and you don't see it. Or if this is a homework question and you look at the back of the book and you're like, oh, that is not what's in the back of the book. So let's go ahead, just review, because I know you guys have that test to come in. Do you guys remember how to FOIL? First, outer, inner, last? No? Oh, we'll just do, we'll review FOIL. F-O-I-L. Or, you know what? If you don't remember FOIL, we'll do it with the area method. Oh, this is great, because we can do what we did before. You ready? If you like to foil, foil. If you're like, I don't know what she's talking about. Look. We're going to multiply. Do you see these are multiplying? Do you see that's multiplying? We're going to do it the area method, where it's n minus 1, n plus 1. Yeah, we'll do it this way, because this is Engaged New York right here. You ready? Remember, we multiplied where the row and the column intersected. So what's n times n? N squared. It doesn't matter whether it's numbers or expressions. It's going to be the same. Negative 1 times n. Negative 1n. Perfect. Or just negative n, however you want to write it. So 1 times n. This one and this one. 1n. And then negative 1 times positive 1. Negative 1. Do you see, if kids learned the area method for multiplying in 4th grade, when they're doing this in 6th and 7th grade, it is no harder. It's the exact same thing. Like the transition is effortless. They don't need to know FOIL. They just do the box method, which they're already used to. Do you see what I mean? All right, so we've got n squared. Then we have a positive n. We've got a negative n and a minus 1. So what does that simplify out to? Yeah, plus 1, minus 1. Those guys cancel. So this is n squared minus 1, and then plus the 2 little squares from the get-go. N squared plus 1. Perfect. So that's if you see it with the rectangle and the 2 little things sticking out. Now, Sean said he gave me the He shook his head and said, I did not see it that way. You saw it with the square with the top and bottom. That's pretty common. Sean said, I did not see it that way. And a lot of people see that this as a top and a bottom, and then because we're drawn to that nice square shape in the middle, like that's really comforting squares. So let's do it that way. You ready? Can I cover that one up? Are we done? All right, here we go. We got this. So, top and bottom.
The square weight takes a lot more than that.
Really? I don't think so. Because the lids are so easy. They're just the position. So we've got this inner square and then a top and a bottom. So inner square plus a top and a bottom, which happen to be the same thing. I bet you can see that the top and the bottom are the same thing. Yeah. Okay. First, second, third, fourth. Okay. Are you ready, Allie? Putting you on the hot seat. We'll do the square first. What's the dimension of this square right here that I shaded in? Do you see it? What did Sean just say? Oh, good. She can hear you. Okay. So what's this? What's the bottom? How many squares? 3. And then this top is? Or the side? 3 by?
5.
No, just the inner square. Here, I'll outline it. Just the inner square. Do you see it? What I can't even tell with that. Here, let me color it in. This guy right here. 3 by what? Do you see it? Don't go all the way up to the top. It's just this 1, 2, 3. Do you see it 3 by 3? Yeah. Okay, so the fourth one is 3 by 3. What's the third position? What's the square? 2 by 2. Do you see that? The second position is a 1 by 1. And you see there is no square. That's why it's 0 by 0. Like I just ignore it. But you see there's no square. So it would be 0 by 0. That's why it doesn't exist. Okay. So the fifth figure, do you see the pattern? What would the square be? 4 by 4. So as soon as you see that, you know how to do the inner square. For the nth term, then it's
N minus 1 squared plus 2n.
hold on, n minus 1, whoops, times n minus 1. Yep. n minus 1 squared. Yeah, but we're going to leave it like this so that we can actually do the multiplication out to get it simplified if they give it to you on the certification exam. Does that make sense? N minus 1 times n minus 1? It's one less than whatever position you're in. We okay? Do you see it, Hannah? No?
I see it. I've seen it in like the first way we did it, but this is not how I seen it.
Oh, that's okay. You don't have to. It just depends on how if you don't have to see it this way if you don't want to. But I was just playing with the squares. And like the second is 1 by 1. Third,
So it's up
2 by 2.
1.
Yep, it's down by 1.
Okay.
Okay, now let's do the top and the bottom. So the top is how many if we're the fourth position? 4. And the bottom is 4. 4 plus 4 if we're the fourth position. How many's in the third? 3 plus another 3. So 3 plus 3 if we're in the third position. 2, second position. So for the fifth position, it would be that plus what? How many 5s? Yep, plus 2 5s. We okay? So now if we're in the nth position, it'll not be 5, it's going to be 2. What is Jenny? 2 what? I'll cut you zoning, sorry. Fourth position, 4 4. Third position, 2 3s. 2 2s. Fifth position, 2 5s. So n would be 2 n's, yeah. Be good? That does not look like the answer we just got at all, right? What did we get before? What was it? N squared plus 1? N squared plus 1? Okay, so let's simplify it. See if we get n squared plus 1. So just to review, and aren't you glad this is a part 2? You take it or leave it. You can do this one on the part 2 or not do one like this on the part 2. You'll see there's a couple on WebAssign. Here, we got to get you on WebAssign. I keep saying that. I keep forgetting. N minus 1 by n minus 1. Okay, where's Erica? Erica? Okay, hit me with it. What's going to go in this box?
N squared.
Perfect. N squared. All right, Mac, what's going to go in this spot?
Negative n.
Negative n. Okay, Hannah, what's going to go in this spot?
1n.
Yep. And I'll just make it negative because it's a negative 1. Negative 1n, negative n, same thing. And then what's going to go in this one? Yeah, negative 1 times negative 1 is 1. Okay, so we'll have n squared minus n plus 1. So this is going to simplify to n squared minus 2n plus 1. Do you see that? And then we got to bring down this plus 2n. Whoa. So they cancel. Do you see it? So it doesn't matter how you see it. You're going to get the same answer multiple choice wise. And I think that's probably why they give you multiple choice. So that regardless of how you do it, if you simplify it down, it'll eventually come out to the same answer. No matter how you saw it, it'll be the same. It's a beast. I don't think they get as hard as that. That's as hard as they get. That is really hard. You have one similar to it in the homework that I, remember at the bottom. Do you guys remember the bottom? These lovely problems. There's one like it, but it's similar, but it's like a C shape that evolves. It's kind of beastie, but you do it the same way. You break it apart however you see it, and then you'll end up. It just depends on how you break it apart. Yeah, come. There's tons of different ways to do it. Yep. So if you just saw it as n squared, like you just saw it, it's like that term plus 1. Perfect. Yep. Perfect. All right, last little bit to this section. This is well repped in those tests, the concept of a function. It is well represented. Wait, where did I put that one? All these little pink things all deal, like just glancing through it, and I'm only on like through the 16th problem. The rest of these are function ones. All functions off like this. So it's big. It's well represented, and I only hit problem 16 so far. So we'll play with those next week. You ready? So the concept of a function is huge. And I do the same example. So if you had me like for 1215 or 980, you've heard this example because it's a good one. So this is out of the NCTM standards, which I'm sure is similar to Engage. The concept of a function is an important underlying concept in math. Have you guys heard of the word function? The whole input-output concept? All right. So let's look at the definition, and then we'll think about an example that I usually give, because it just makes a lot of sense when we talk about it. And then we'll apply it to all the different ways a function can be represented. You with me on this one? This is big. Very well read on the practice exam. So the rule is it's very mathy when you first read it. So they talk about it's a relationship. I like to just say it's a rule of correspondence between two sets. Typically, we call the first set the domain. The inputs are called the domain. The second set of values of the outputs we call the range. But here's the kicker. That every member in the domain gets mapped to one and only one element in the range. That's the coolness of a function. It's very cool. So let's talk about a function that I used with my previous, a long time ago vehicle. And so maybe some of you, so my dad, maybe some of your parents have done this. Maybe do this. My dad had a notebook in our station wagon when I was growing up. And no one ever wanted to sit in the front seat, but whoever was stuck sitting it's weird how when you're little, you don't want to sit in the front seat, and then all of a sudden you want to sit in the front seat, like all my kids fight over the radio and the aux cord stuff. All right. No one wanted to sit in the front seat because we had to do this thing for my dad. So when he filled up the tank, we would have to record the mileage, and he would tell us how much gas he put in the car. And he did this, Sean, why did he do this? Why would this man do this every flipping time in the notebook?
Making sure his fuel economy was right.
Yes, and if it was off, it told him, something's wrong with the car, Kathleen, we got to get this tuned up. So if it varied, he was alerted. I don't know why that is the case, but Sean is nodding his head like it's common knowledge. I don't do this, but my dad would go through notebook after notebook.
You don't have a carburetor in your car.
Okay, I don't know, but we had to do this for the old station wagons. So this is a common thing back in the day, to be very focused on your mileage for your car. Now, I had one of my first cars was a Jeep Wrangler, and this is true. It was a 20-gallon tank, and I lived in Philadelphia at the time, and it got 20 miles per gallon. About 20 miles per gallon, we track it. Now, the problem was that my husband would ignore the little light that would come on, the indicator that perhaps you ought to think about getting some gas, right? He was always of the belief, do you know, Sean, how many gallons are left when that light comes on?
It's supposed to be 50 miles.
Oh, I was like gallons of gas left in your tank. Oh, really? It's by miles?
It's supposed to be by miles.
Oh,
50 miles before empty.
I never knew that. Okay, good to know. I didn't know that. So he was always like, oh, we're fine. We're fine. No lie, we ran out of gas on the way to a wedding in New Jersey. And so I'm like, we are not fine. And so after that, I made my husband always fill up the tank completely, hit the little mileometer button, and so it was always at 0, so I could track. I don't know what it's called. Mileometer? That makes sense.
Odometer.
That to me is how fast you're going, but clearly that's not right.
Speedometer.
Okay. My car knowledge is lacking. Wait, what is it called?
Which one?
The mileometer thing.
Odometer.
Doesn't mileometer make more sense? Right? All right, I'm going to call it mileometer. All of my children call it a mileometer. I don't know what it's called. I make up words every once in a while. And so my son was playing over the summer. We were with my family. And I always call, like, the best of something, like the nib. I don't know why, but I made up this word. So like, yeah, like, you know, like you listen to a song and there's like the best part, like you love the certain line, it's the nib, right? Or like when you're eating pizza and you have that bite that's like super cheesy and saucy, that's the nib of the pizza, right? And so my son used the word nib in Scrabble, and my brother challenged him, which it actually is a word. It has something to do with the pen. But my brother challenged him. He's like, it's the best of something. And I'm in the kitchen going, oh no, because I totally made it up and I use it all the time. And my son was really mad. And I make up words like, they've heard me say myometer before. They don't know I made it up. But I make up words. So if I do make up a word in here, like I'll say middleist a lot, which I know it's not a word, but I'll use middleist. Smallest, largest, middleist, right? Okay. Anyway, so we got the mileometer. So I would make him hit 0 on the mileometer. And then if I got in the car, you know, if it said 20, how many gallons of gas had he used up? It was a 20-gallon tank. It got about 20 miles per gallon in the city. So I get in the Jeep, I look at it. How many gallons of gas did he use up? 20-gallon tank, 1, right? That is a good function, right? I get in, here, let's start writing it down. Let's do my little table. So this is my input is the mileometer reading. And the output, so you can use X, we can use M for mileometer. And then the output is the number of gallons of gas used up. Now, we're always so stuck on X and Y. I'll use it, but we're going to change it. So this is gallons of gas used. Tables are very popular. So I said if the mileometer read 20, there's 1 gallon of gas used up. So that was good. So I was comfortable. I knew what was going on with the tank. All right, so if I get in the Jeep and it said 100, how many gallons of gas have I used up? It was a 20-gallon tank. It got 20 miles per gallon. Sean said 5. I've used 5 gallons of gas. Does that make sense? Let's do 200. How many gallons of gas have I used up? 10, right? Does that make sense what we're doing? This is an example of a function, right? I'm giving you one number, like 40, and you're telling me one number back. Do you see how it gets mapped to one and only one number? So if it was 40, what would it get mapped to? 2. That's the coolness of a function. You put one number in, one number gets pumped out, okay? A very popular way to represent a function for kids is with tables. I can't find it, but I had a problem of the day from one of my kids that had I think I wrote down, it was a function machine. So this was 3rd grade. So they had function machines in 3rd grade on those problems of the day, and it looked something like this. If any of you guys have kids that have function stuff, I don't bring it. Thank you. It had something like this. So it had all these pictures of like these machines chugging. I gotta just find it. I moved offices, so I have stuff not organized. And so this is like what it did. Again, this is 3rd grade. It went like this, and then it would go like this. And it would go like this, and then it would go like this. And so there was a whole series of this, and you had to figure out what the rule was to the function machine. So then it would go like, so then they would have, I drew it wrong. Okay, so then it would be something like this, and then it would go question mark. So they wanted to know like what the rule was for the function machine. And it's a really nice visual for 3rd graders, right? They see one number going in, one number coming out. One number going in, what number coming out. So what's the rule for this particular function machine? What's happening if this is going in and that's coming out? 3. They're adding 3. So then on the problem of the day, the kids would write 12 because it was adding 3 each time. But it's a cool visual. One number comes in, one number comes out. The number that goes in is the domain. the number that comes out is the range. Those are the mathy terms. There's two other mathy terms to it, and I'll give those to you in a second. In second grade, did you all have like a favorite elementary school teacher? Mrs. Hamilton, second grade. Oh my God, I love that woman. And she was really ahead of her time. So in second grade, we all had to bring in, now keep in mind, I was very young, we had to bring in shoe boxes. And we made, I didn't write down, we made function faces. And so we brought in a shoebox and we made a face. So here's the shoebox. Like here's the, and it had, we made eyes on it. Mine had yarn, yellow yarn hair. She was beautiful. And then she had a mouth. The mouth was open. This looks like a terrifying one. And then the tongue was sticking out. So we made a face, and then the teacher cut a hole and glued like a tongue coming out. So she must have put something, like a shoe inside it and then glued the lid on. So you could feed, this looks terrible, but you would feed a card in her forehead and then out would spit out, like the card would turn and then out would come a number. So like I don't know, I'm not describing this well, but I love the function face station. So she had decks of cards. And so the rule was like add 2, like we're in second grade, right? That was the rule. So you'd see like number 5 on the top and you'd feed it into your function face and it would just turn around in the shoebox and then out would come a 7. You tracking me? And so you would do this because apparently I wasn't bright enough just to look on the bottom of the card. You would feed it into your function face, right? And then you would have to figure out the rule for that stack of cards. She didn't call it a function. She just said, put it in your function face, right? So it's really cool in second grade where we're using that rule, that word function, associating it with a rule on a card. Does that make sense? So second grade, we were talking about functions when I was little. Old McFunction, that was a song I sang in 6th grade with Mrs. Stranton. She would sing, Old McFunction had a farm. There's a lot of verses to it, but it would go E-I-O-O-O. E-I-O-O-O. And there were words to it, mathy words to it. But it was every input has one and only one output. Seems like there should be more O's in it, but I remember it was E-I-O-O-O. Every input has one and only one output. That was 6th grade. So now I did it in 2nd. My kids did it in 3rd. I sang the song in 6th grade with Mrs. Stratton. And then my mom was an elementary school teacher, and she taught 6th grade math. Okay? And so I was talking to her, and she said that transition, when kids would come in, so she only taught math. So when kids came in, every class, they would be like, oh, I want to do what's my rule. So she'd do a thing called what's my rule. And she would say like squared in her head. So shout out a number like 9. She'd go 81. This is 6th grade. They shout 4. They'd say 4. She'd go 16. And they'd have to figure out what the rule was, right? So they're getting this idea. They're giving her one number. She's giving one number back. Do you see it? So that's the coolness of a function. You use functions, right? When you shop, say you go to Kohl's and they blip your clothes, right? The tags, bloop, right? It's not the price that, if you're in New York, it's not the price that's on the tag. It's always a little bit more, right? Because of tax. So when you're done scanning, they don't say, well, you can pay $50 or $60, it's up to you, right? No, there's a function in that cash register that adds it up and multiplies whatever the state is and whatever county that is.
4% for clothes in New York.
What is it?
4% for clothes, 8% for other things. Food is non-taxed.
But what's like, if I go to Kohl's and I buy something, it's more than 4%.
If it's clothing item, it's 4%.
Really?
I believe so.
Oh, I didn't know that. I thought it was like 8% or something.
That's for other things.
Like
Food is
tobacco
non-taxed.
I didn't know that. Oh, I didn't know that. So that's how the register's programmed. They don't give you 2 choices, right, for what to pay. So there's a function in that cash register, right? Okay, so anyway. So hopefully you got the idea. So you got a table. Ordered pairs often get matched up with, like they give you ordered pairs. Oh, and they do ordered pairs very early on, third grade. Third, right? Oh, you're in third grade. Do they start graphing?
Yeah.
A parent shared this with me last year. I brought a graphing folder, if I can find it. And their kids were doing graphing in third grade. I was like, wow, that's so early. Oh, if I can find it, that would be helpful. Yeah, so you're in third grade over at Camp L?
Yeah.
Let me just show. Oh, yeah, here it is. These were their third grade papers. That was one. So they were plotting ordered pairs in third grade. So this was, they weren't plotting them. I don't even know what this is. I just remember she said they were in third grade. Oh, right there's the ordered pair. Now, they're not number. It's like Battleship, right, with a letter.
We're using the ordered pair to find what letter it is and make the word. So that'd be like a spelling page,
Yeah,
pretty much.
but math.
Yeah.
Across the curriculum. And then someone here brought this, third grade. Now this is much harder because it's number. It's not like Battleship, right? Where it's letter number. So they've got to know the first one goes left or right. The second one goes up or down. Third grade? Third grade,
So we
that's
do a lot of
early.
that stuff.
What?
We do a lot of that stuff.
With Common Core?
Yep.
Yeah. Okay, I just went to push up my glasses again and they're not on my face. All right, ordered pairs. So ordered pairs, it goes first, input, output, right? Input, so you can represent a function with just a bunch of ordered pairs. Input, output. I'm just taking these off the table because we're gonna plot these in a minute. So that's one way, table. Two ways our book talks about ordered pairs. Third way is with a formula. Okay? So with the gas example, what was the formula? What's the pattern that takes you from 20 to 1? That takes you from 100 to 5? If my input's X, how do we get to the output? Yeah, you divide it by 20. Whatever I give you for X, you guys were dividing it by 20. There's your rule. So X was the gallons of gas. No, X was the mileometer reading. It's hyphenated. So you know. Mile-ometer. But I'm going to say mile-ometer. Because that's how I've always said it. Mileometer. G is the gallons of gas used. Oh, I just lied. Hold on. G is the name of the function. G is the name of the function. This is what's called function notation, and we'll talk about that in a minute. And G of X is the gallons of gas used. So let's talk about this notation. No longer do we call everything Y. No longer do we do that, right? You guys are used to Y equals X squared. Y equals X minus 1. Isn't that how you guys learned it? Y equals MX plus B. Do you remember doing that? Okay, no longer do we do that, because if I said, everyone, let's look at Y and evaluate Y for 2, they're all named the same thing, so that's silly to use that notation. Y equals every time. So this is what's called function notation, where we get to name it something different. So for example, I could say f of x equals x squared. So the name of this function is f. I could say h of x equals x minus 1. And then I could say k of x is equal to 2x plus 3. So now if I said, all right, let's evaluate k for 2, you know which function I'm talking about, right? It's what's called function notation, and that gets introduced in 6th grade. Instead of everything y equals, y equals, y equals, we name it something different. And I talked about this, I think, in your class. Do you remember? What did George Foreman do? Who's Foreman? And he's not the grill guy. What's George Foreman famous for? He's a very famous heavyweight champ. He did something, don't say it if you know. What did he do? Does anyone else know? What did he do that's very odd? How many kids did he have? Do you know?
8,
He had 8 kids. I think 1 girl and 7 boys.
3 girls, I believe.
3 girls, 5 boys. But the girl names are unique too. He named every single boy George.
No, he named every kid.
I thought he named the girls Georgina. He even named the girls George? Right, we look at that. Yeah, Jenna's like, what? That's weird, right?
All 8 of his kids.
Isn't that weird? But that's just as weird of calling every function you name Y. There's no different. Like, that's weird. Calling everything Y equals. That's like being George Foreman and naming all your kids George. That's weird. That's not normal. So that's why we have function notation. So we can name functions different names. And that's what the little letter is. It's just the name of the function. You tracking? All right. And then last little thing is practical domain and practical range. So they ask in the book on WebAssign, and we will get someone into WebAssign today. They talk about the practical domain. Now remember, the domain's the input and the range is the output. It's not always, this is making me crazy, this mask. It's all fuzzy. It's all fuzzy. I've had it on, so it's like, I feel like it's like there's a stuffed animal on my face right now. It's so fuzzy. It's tickling me. All right, the practical domain is the inputs that make sense for the story. So the domain here was the mileometer reading. So what kind of numbers work for a mileometer reading? Positives. So no negatives. Will 0 work? Yeah, I get in the car, you hit the mileometer, it goes to 0. Is any positive number work, which would be the coolest car ever? Yeah, I ran out of gas. So at some point, there's the largest mileometer reading on that tank. So what I say was a 20-gallon tank, 400. Good, Jenna. Yeah, 400. So the practical domain for this, for the x's, is stuck between 0 and 400. Does that make sense? They'll ask you about that, about what's the typical domain. Now the range is the gallons of gas used. So what can you tell me? Gallons of gas used up.
It's, y is between 0 and 20.
Perfect. Victoria hit it. It's any value between 0 and 20. Right? Because it's a 20-gallon tank. So it has to end somewhere at 20. How we doing, okay? All right, so far we've covered 3 ways. Table, ordered pair, and formula. The last way is with a graph. And this is a popular way starting in 3rd grade. So the inputs go left or right. Do you guys remember that? The inputs are often called the independent variable. We're going to see that in the next section. The independent variable is called the inputs. And so what was our input, the left or right? What was the input values? They were the mile readings, right? Okay, so these are the mileometer readings. Okay. All right. And then the output is often called the dependent variable. Because it depends on what you put in for the input. Right? Doesn't the number of gallons of gas used depend on the mileometer reading? Does that make sense? Independent, dependent. All right, so this was the number of gallons used. So I think I did 20. And I think if you go by 20s, you'll get the mileometer reading in. So I think if you go 20, 40, 60, 80, 100. I think if you do that, you'll get, you'll stop at 400. And then up and down, I think you can get to 20. So you can get the whole graph in. And you could just plot a couple of the pairs that we have. Oh, you can barely get it in, yep. So take your time, flip it over, pick a couple points, and plot them. You're gonna see that this is a pretty decent, recognizable graph as far as its shape goes. And let me tell you, there were a bunch of those in that review for graphing. There was a couple slope questions. You guys remember slope? Anyone with slope? That was on there. It's like, oh, usually I don't cover slope, but we're going to cover a little bit of slope because we're going to pop some questions in that review packet. Because we do graphs, so we may as well hit slope slightly, right? Slope was in there. What is it, Jenna? Jenny, you're Jenna. Jenny, what does it look like? The shape when you plotted your points. Oh, okay, plot your points. I'm looking at Victoria's. Yours is looking good. Plot a couple. You probably don't need that many to see the shape. Justin, what's it look like?
Just follow the line you have.
Yeah, it's just a line, right? Should come out to be a nice looking line. I'm losing it here. 2010, 210, 210. It should be a line. Now be careful. You don't want it with an arrow on the end like we're so used to, because it doesn't go off to infinity, right? It ends at 420, right? When you've hit 400 miles, you've used all the gas up, and then you're on the side of the road in New Jersey, missing your roommate's wedding from college. Okay. So, you draw it. Just make sure you don't put an arrow on the end. It should end like that. It doesn't extend on. Hopefully yours is a little bit better than mine. Make sense? Very popular way. What kind of slope is that? Positive or negative? Do you guys remember slope? Yeah, it's positive. When you go from left to right, if the line rises, it's a positive slope. Okay, we'll talk about like how to find the slope in the next class. All right, the last little bit to this section is mappings. So these are very popular ways for kids to understand the idea of a function. So the first column is your input, the domain, the independent variable, right? There's all these names for it. And the second is the range. So if I say 1 is the input, what are you going to say the output is? A. You only told me one thing. If I say 2, you're going to say A. If I say 3, if I say 4, yeah, so that's a function. I said one thing, you said one thing back. That is a good looking function. Yeah, Mac.
Technically, I thought, like, aren't there some where you're not supposed to do that because it's like, isn't that a piecewise thing?
Yeah, we're gonna do piecewise, but it's technically called the piecewise function. Yeah, we're gonna look at a piecewise in the next section. Yeah, but it's a babysit.
Like, that's not possible if you were, like, because if they both go to A, right? Or is that?
Nope.
Or that's if you have two X's. That's
Yes, here, let's look at this one.
I switched that.
Okay, so if I say 1, you say A. If I say 2, you would say A, right? As long as, if I say one number and you tell me one number back or one letter back, it's a function. But this one, if I said 1, what could you say?
A, B, or C.
Yeah, then that's not a function, right? If I tell you one thing and you give me more than one thing back, it's not a function. So that's a real nice visual for kids when they see that. So here, let me look at what Mac was just talking about. Let's skip to that section. So I think it was, it's 6.3. Let's skip to talk what Mac was just asking about. We'll come back to 6.2 later. It's not a big deal. All All right, so this is what Mac was talking about. This is an example out of the, I think, WebAssign. I think out of WebAssign. So look at NP number 4 for, what's CC, what is that? CCSS. Common Core State Standards. Mathematical practice number 4 says modeling to help represent quantitative relationships. Quantitative means there's got numbers in it. All right, so go ahead and see if you can fill in. Oh, this didn't photocopy. Very nice. These values, I sent this to Printing Services in my defense. These values are supposed to be over here on the table. So we'll fix that. But here, let's read the scenario, and then we'll map it a little bit better on the table. Everything got shifted. Okay, so Ellen's going to babysit. And she says, I charge $8 per hour and $4 for every half hour. So that makes sense. But any time over 30 minutes, you got to round up. So if you're gone for an hour and 45 minutes, what's she going to charge you? 2 hours. Okay? So this is how she bases it. And so if it's any time over, so what do you think if it's between the hour and the half hour, she's going to charge you for that time that you're gone. What do you think? Like if you're gone for an hour and 15 minutes, she's going to charge you the hour and then the extra half. Okay? So I want you to determine, is there a relationship and how much are we going to have to pay Ellen? So let's just see if we can figure it out. So these are supposed to go over here. So 1 hour, what's she going to charge us? 2, what's she going to charge us? 3, 4. So these are hours that she's babysitting, and this is going to be money. So 1 hour, 15 minutes. You see it got shifted in the translation. 1 hour 30, 1 hour 45. So this is what Mac was talking about. So start filling some of these values in. And then we'll do another one like it. So 1 hour, what would it be? $8. 2 hours. 16. 3 hours? Yep, 24. 4 hours? How much you charging an hour? 32. Okay, $8. All right. So those make sense if you're right on the hour. All right. So what happens if it's an hour and 15 minutes? Yeah, $12. What happens if it's an hour and 10 minutes? Yeah, $12. What happens if it's an hour and 25 minutes? It's $8 plus the half hour. She rounds to the next, like she rounds up.
Anything up to the half hour, so $12.
Yep, anything up. So we have lots of choices, Mac. 1 hour, 5 minutes, $12. 1 hour, 15 minutes, $12. Do you see what I'm saying? Okay. So then at an hour and a half, that's still $12. Then she kicks it up a notch. So anything above an hour and a half, she's going to go up to how much then? Yeah, she goes up to the 16. She's really charging 2 hours. We okay? All right, so let's plot it and see if it makes sense. So it's definitely a function, right? You put one value in, there's only one option out, right? We look at the clock, we know how long we've been gone. She's going to charge us one value. There's no wiggle room. All right. So let's label. So this is going to be the hours you've been gone, and this is going to be the money she's charging you, right? So we'll just have to eyeball. So if it's 1 hour, where are we going to put my dot? Somewhere closer to the 10 than the 5, but not by much, right? All right, but let's split it. So what happens if it's a half an hour? So 0.5. If it's a half an hour, what's she going to charge us? We've only been gone a half hour. $4. And then $4 if it was anything up to the half hour. Do you see what I mean? So if we were only gone for 5 minutes, she's charging us $4. I'm gonna talk why I put that open circle there. And then, so it's $4 for any time between 0 and 30 minutes. This is 30 minutes. Half hour is 30 minutes. Right? And then anything above 30 minutes to 1 hour, what is she charging? For anything between 30 minutes and 60 minutes, that hour, what did she say? She's rounding up. $8. So now look, after 30 minutes, I'm going to put this little open circle there because I already know that the 30 minutes is $4. So then I'll put an open circle and then she's going to charge us $8 for anything between 30 minutes and an hour. Now look, if I filled this in, do you see that would break the function rule? Because if there was a filled in circle here and a filled in circle here, that means at the half hour, there's 2 choices. Not allowed to have 2 choices, only 1 choice.
I don't know why I'm confused. Where did you get those numbers to put there? Like
The $4 and the $8? Oh, up in this little paragraph.
Okay, so that's where you get it from.
Yeah, yeah, from her description. She said, I'm charging you $4 for a half hour, $8 for a full hour, and then I'm rounding up to the closest. I'm rounded to,
the number that you're.
Yep.
what you're- Okay.
Is this
Okay.
called a step function?
yeah, it's a piecewise or a step function. Yeah, it's an example of a step function. All right, so everything's changing on the half hour, right? Like something's gonna give. So this would be 1.5, 2.5. You with me on that? Like every half. All right. So if I'm gone, I'm paying her from anywhere to an hour and an hour and a half. What am I paying her? $12. Okay. So I know at an hour it's here at 8. So now I'm going to put an open circle because I already know how much we're paying her for an hour. Then anything above an hour up into the hour and a half, you guys told me is $12. Does that make sense? Any time between an hour and an hour and a half, we got to pay her $12. And then what happens after the hour and a half? Yeah, she said, all right, you're closer to the 2-hour marker now. So anything from an hour and a half on, we got to pay her $16 up into 2 hours. You guys getting the pattern? So the moment I'm gone, a second over 2 hours, she's charging me what? The 2 hours plus another $4. Do you see that? So what's that come out to be? 20. Okay. So at 2 hours, I know she's already charging me that much. But then if I'm gone a little bit over 2 hours, up into the half-hour mark, she's charging me $20. Are you tracking it now? Do you see it? So this is kind of what Mac was asking about. So you can have the same output, right, for different inputs, but for one input, there's one and only one output. It can be the same output for a bunch of inputs, but it's only allowed to track it once. Every input, there's one output. Here, I photocopied the key out of the back of the book. That's what it looks like. So for half an hour, 2, 4, 6, 8. This must be 4. 2, 4, 6, 8. This must be 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's the answer. But this is the grid they gave you off of WebAssign. It was weird looking. So let's practice. All right. So if this is an hour, this is a half hour. So a half hour, $4. Anything between a half hour and $1, you got to go up here to 8. As soon as you get anything over 1 hour, you go up to 12. Do you see it? After an hour and a half, you go up to the next $4 jump. So she just keeps jumping it by $4 every time. So that is what is called the piecewise function. Because it's a bunch of pieces. It's not connected, it's not continuous, it's just a bunch of pieces. Are we loving on it or do we hate it? There's one about buses in the homework. Here, you know what? Let's get someone to come up here and do WebAssign. Has anyone signed up for WebAssign? Mac, you want to sign up just to see what it looks like? Yeah, you do. Okay, you ready? All right. I'm going to stop this.